Welcome, Algebra 1. I hope you all are enjoying a great week. We're going to jump into lesson 36 today, and we're having lots of fun with our distributive property. Now remember, math is always fair. Even in a world that it's not always fair, math always is. So when we're distributing, we want to make sure that we're doing that evenly and fairly. Then we're also looking at negative exponents and minus signs, so making sure we handle those properly. So let's take a look at our practice, and we'll kind of work backwards as we work some of these problems. So it says expand by using the distributive property. So x squared over y is being distributed to x squared over y minus 3y squared over m. So our book is just wanting to know, as we distribute, that we're making sure that we distribute it fairly to all, right? All right, so as I solve these, it would just be x squared, it's numerator to numerator, so I have same base, just add the exponents. Y times y, y squared, minus 3, and there are no x's, so it's just going to be separated, over my. Now these are not like terms, so I can't combine them together. So that's all I'm doing there when I distribute. Now let's take a look at letter C. So letter C says -4 to the -2. Now be careful, friends, because this is not the same as this, right? Now this would say my whole base is -4. Your book teaches to actually cover that up and bring it over at the end. But I want to make sure we are not saying that is the same. So the -2 is only what it's touching. So we could rewrite this -1 times 4 to the -2, right? So -1 times 1 over 4 squared, because my base is just getting flipped down to the denominator. So my final answer would be -1 times 1 is -1 over 4 squared is 16. So it would be -1/16 is my answer. Now let's take a look at letter D. Same concept, because I have 1 over -4 squared. No parentheses, so the negative stands at the very end. So it would be the same as saying 1 over, and I don't have to move anything. Oh, I'm sorry, I missed the negative exponent. So I do have to flip it. So this gets flipped up, so it would be 4 squared, but this is still -1. So my final answer is -16. How come? Because I had one negative, it wasn't in parentheses, so it's not -4 as the base, it's -1 times 4 to the -2. All right, now let's take a look at letter E. So letter E, I've got -4 to the -3. Woo, they're throwing a lot of negatives at us, friends, aren't they? So this is just -1. This -3 means that I'm multiplying, and it's 1 over -4 cubed. So I've got 3 sets of -4. So that would be the same thing as saying I've got -1 times this would be a 1 negative here. Then I've got 3 more negatives down here. -4 times -4 times -4. So I've got 1, 2, 3, 4 negatives total. My final answer is positive. 4 times 4 is 16, times 4 is 64. So 1 over 64. And it's positive. How do I know that? Because I had 4 negatives. 1, 2, 3, because they were in parentheses. Over here, there weren't parentheses. That's why I did not use it. All right, so make sure you're on the lookout. Letter F is a little bit tricky as well, but it has parentheses and a negative, so be on the lookout for that. So that is lesson 36. Lesson 37 is inequalities, greater than, less than, and solving those. So the most important part of these, and you've probably covered this if you had a pre-algebra type class, but the most important part about your symbols of greater than, less than is whether or not it includes the point. So I've got on lesson 37, greater than, less than. Then I've got greater than or equal to and less than or equal to. I've had students say those look like emojis, right? So anytime that you're saying greater than or less than, it goes up until the point, but not including the point. So it's always an open circle. If it's or equal to, and they have that one line underneath, the dot is going to be shaded. It means it does include the point. Now, one thing I want to point out to you is there's an extra mark here, so there's an extra mark inside. So that's one way I remember it. This or equal to means it does include the point. So if I'm looking at a graph and your book says draw a number line and graph the solution, x is less than or equal to 5. So here I am at 1, 2, 3, 4, 5, 6, 7. If x is less than or equal to 5, because I've got the extra line here, I'm going to put the circle and include 5, so I'm going to shade it in. Now, it's less than, it goes this way. I had a student one time say, Miss Moorfield, did you notice when x is first, it points this direction? So that's actually when your variable's first, the symbol points the direction you're going. X is less than 5, including 5, so we put the, now if it were just less than 5, it would be an open dot. Because it does include 5, that's why we close the dot, because the solution can also be 5. If it weren't, it could be 4.99999, but if it was not or equal to, it could not include 5. In this case, it does because it says or equal to. Letter B, write an inequality that describes this graph. Well, the graph looks like this. Here's 4. It's an open dot, and it is going to the right, and it includes 5, 6, so on and so forth. So I know that x is in relation with 4. Now, because it's more than that, I would say x is greater than 4. The dot is open, so it's not or equal to 4. So it could go right up until 4. It could be 4.00001, but it can't be 4, right? So x is greater than 4, but it's not including it. So that's how I write that. So that's lesson 37. I hope you all have a great week, and I look forward to meeting with you again and covering a few more lessons. God bless.